Hey robot makers, hope you're having a good day so far. So do you want to know how to build PCBs, how to design PCBs using Fusion 360? Then this is the show for you. Let's dive straight in. My name's Kevin, come with me as we build robots, bring them to life with code and have a whole load of fun along the way. Okay, let's get over to our keynote today and start looking at this. This is so cool. I've been waiting to show you this for a while now. So we're going to have an overview of what Fusion 360 can do. We're going to have a look at some basic circuit design using some components. We're going to do some board layout in the 2D design view, and then we're going to do something which is really, really cool. And I don't know if this is just unique to Fusion 360, but because it's a 3D modeling suite, we can then automatically, magically generate PCBs in 3D so that we can model around them. It's just so cool. We'll also do some custom design of components for our own making. So I'm going to get a Raspberry Pi Pico W. We're going to design this in Fusion 360 electronic design. So we're going to see how that all can fit together. And if you're here for the live stream, we'll have a bit of a Q&A and hangout as well. I've got quite a few things in my mailbox to show you as well at the end. Cool. So why this? Why not use something like KiCad or Eagle? Well, Autodesk announced earlier this year, June the 7th, that they are no longer going to support or sell Eagle, which they bought a while ago, but they will continue instead to invest in Fusion 360 electronics. So essentially they've taken all the best bits of Eagle and they put it into Fusion 360. So if you've used Fusion 360 before, you might not be aware that it has all this functionality built in. So we're going to have a look at this today. So designing PCBs with Fusion 360, it's kind of a three-step process, and you do kind of go between each step kind of iteratively and go back and forwards. It's really quite neat how it does this. So you start out with a circuit diagram, very similar to something like KiCad or Eagle. You'll put all your components on there from a library. You can then go over to the PCB board layout. Again, I think this is a bit like fritzing. If you ever use fritzing for doing component layout and so on a breadboard, this is very similar. So you have these air wires that you have to then make into proper routes using the net command, and we can then build up a proper PCB that we can actually manufacture. But it doesn't stop there. This is Fusion 360, so we can then push that into a 3D model and it will automatically show you those components in 3D so that we can then design a model around it. So the reason I was wanting to do this, I've had for quite some time this remote control I was building originally for a Smars robot. And this was way back before Bluetooth was even a thing. I've even got a Bluetooth module just here that I was going to plug into this Pico. And I did get so far, but I realised that if I wanted to have the sort of up, down, left, right buttons on there for controlling something by Bluetooth, then I would need to have basically a custom PCB. So this was my quest to build a custom PCB using Fusion 360. Okay, so we have got a sponsor today, and it's quite appropriate, our sponsor, because it's PCBWay. I can't think of a much more suitable sponsor for today's show, so thanks for sponsoring the show. This video is sponsored by PCBWay, your ultimate destination for all things PCB manufacturing and assembly. Whether you're a hobbyist, a startup or a seasoned professional, PCBWay has got you covered. PCBWay offers an impressive range of services. They provide high quality custom designed printed circuit boards for any application you can imagine, from single layer to multi-layer, flexible and even rigid flex PCBs. They have the expertise to bring your designs to life. PCBWay ensures fast turnaround times and affordable prices without compromising on quality. With their state-of-the-art facilities and advanced manufacturing techniques, they can handle small prototype orders up to large-scale production runs with equal precision and efficiency. PCBWay offers additional value-added services such as PCB assembly, component sourcing, and even functional testing. You can trust them to deliver the fully assembled and tested boards ready for integration into your projects. One of the best parts of PCBWay is their user-friendly online platform. It allows you to easily upload your designs, get instant quotes, and track the progress of your orders in real time. Plus, their dedicated customer support team are ready to assist you with any questions or concerns. So whether you're working on an innovative Internet of Things device, a robotics project, or anything in between, PCBWay is your go-to partner for reliable and affordable PCB manufacturing and assembly. Head over to PCBWay.com today and turn your ideas into reality with PCBWay, your trusted PCB manufacturing and assembly partner. Okay. Turn my volume down a bit there as well. I wish that wouldn't pop up. So let's dive straight into it, shall we? We're going to have now look at Fusion 360 electronic design. So I'm going to go over to Fusion 360. I'm going to get myself down here. The first thing I'm going to do is just save this file just so that we can find it later. So I'm going to save this in, let me see, I think I've got a live stream, PCB live stream, and let's just call this 3D model. Oops. Okay. And the other thing I'm probably going to do is just stop it from doing this annoying zooming in, because every time I click a dialog box, it'll keep zooming in and out. And that's quite irritating. Right. So the first thing we're going to do, I want to basically build this model here in Fusion 360 very, very quickly. So I've got some instructions on here, which is basically just a board layout. I'm just going to have this next to me here so that I can see this, but this is a bit of a speed run. We're going to come back to this later and use this as a basis for our PCB. So what I'm going to do, I'm going to create a new component first of all, and I'm just going to call this one case, something simple like that. Oops, why did that go wrong? So let's try that again. Assemble new component. There we go, case. Okay, and I'm just going to create a sketch just on the base there. And what I'm going to do, I'm just going to create the basic outline of our remote control. So it's something like this. And I only have to be crude because we're going to stitch all this together. So let's just make that nice and vertical and use the midpoint to pin that to the middle there. And the first measurement I'm going to do, I'm going to also just draw a horizontal line, not a vertical line even, and oops, it's decided to make that go all the way up there. No, we want that to come down like so. Right, and I want the measurements, these are just rough and ready measurements, just something I've tried and tested. So this is going to be 57.6 millimeters. Because that's in the midpoint, that also means that point to that point is also 57.6. We can put that there as a driven measurement. The next one there is going to be 80, and that one there is going to be 30, going to be a bit smaller, and then this one here is going to be 40. I want it at an angle like so. And then what I'm going to do is basically just mirror these over, so that is equal to that, that is equal to that, that is equal to that. That's the equals constraint there. And then let's have a look what else we need. We need to define some angles. So the angle between that and that is going to be 120. And that's going to be the same there. So that's going to be equal to that. And then we're going to have that angle between this and this one is going to be 105. I think that should be therefore the same, 105. Yep, that's a driven one, that's fine. We can leave that. And I think that is almost it. What do we need to do? We need to define the height of this as well. So let's do there to there. This is going to be 75. There we go. Right, now that all the lines are black on the outline there, we've got a profile. That means that it's a fully defined model. I'm going to round these corners out, but I'm actually going to do that as a second step in a minute. So now that we've got that there, I'm just going to click on the profile, hit E to extrude, and I'm going to extrude up. Let me just see what the measurement is. I've got my notes next to me. I spent all day basically preparing my notes here. Right, so I'm going to do this 20. So it's a nice big block. And then what we'll do next is we'll do those fillets. So if I press F and I basically just click on these, the fillet's going to be 10. So we get a nice round. If I'm holding down the Alt key there, I can actually sort of see through the model. So I can click on things that would otherwise be a bit obscured. I'm just going to move that around a bit there just to get that back one. There we go. So I've now got a nice rounded, kind of like this shape. And the next thing that we need to do is we need to be able to sort of eat into this. We need to give it a shell. So if I click on that shell, click on that top surface and give it a 3mm shell, it's now a hollowed out case. Very, very similar to this one that I've got in front of me here. I think that's probably about 3mm on there as well. Okay, so what I want to do next then, let me scroll down here. I want to create another sketch inside this base here. This is what we're going to use for the basis of our PCB design. So if I click on Create Sketch in there, I then press P for Project. I'm going to pick the outline geometry, which is here. I click OK. We've now got that on this particular sketch layer, and if I click on this offset and then select the edge there, I can then give this, say, I think it's a 2mm offset. And we need it to be -2, so I can click that little flip button there. And what that's actually done is it's created a new outline 2mm within the boundaries of that, so it's offset it that way. So let's click on OK there. And let's finish our sketch. So this profile that we've got here, this is what we're actually going to turn into our PCB board. So the way that we do this, we click on the create here, we go all the way down to the bottom and we say create, and I'm going to create an associative PCB. And what this will do is it will link it back to this particular sketch. Now the only side effect of that is we can't actually place the finished PCB within this particular model. We'd have to create another model, bring this one in, bring in the PCB model and assemble them that way. It's not a big shakes to do that. But the benefit of doing the associative is if I decide to change the dimensions of this base sketch, it will change the dimensions of the PCB. So it's got that link there. Whereas the independent one, it is a completely independent sketch and not related. It's just kind of a snapshot in time and then that's it. So I like to do the associative PCB. So it's going to say it requires saving the source. So I'm going to save that. Click OK. And then what we then need to do is we need to define some orientation for this. So this little create associative PCB, so the profile, I'm going to click in there. So that's the offset profile that we've created. The X axis is going to be this bit here. So you can see that we have the X going along that way. However, our Y is pointing in the wrong direction. So I think we just need to flip the X, do we? Actually, no, that will be fine. Actually, that will be fine. So I'm just going to click OK on there. That's done. And this is now gone into the electronic design part of Fusion 360. So this is what our PCB is going to look like. You can see on there, it's got copper traces, it's got solder masks and packages, but there's nothing in there yet because we haven't built them. So let's go and do that. So the way that we do this is we push this 3D design to a 2D design. So this button here will push this, and it doesn't exist at the moment. So I'm going to say click yes to create that, and then we'll now go into the Design Studio proper. Now it looks a bit overwhelming at first. There's all kinds of buttons and things, and you might not have seen these before. So don't worried about that. We're going to go through this a bit at a time. So what I will do, I'm going to save this at this point. I'm going to click on save. I'm just going to call this PCB. That's fine. And you can see there where it says that the 2D and 3D PCB documents are out of sync. Don't worry about that. That's because it's just created it and there is nothing in there. Now down the bottom we have these controls for sort of zooming in. The one I use most often is this zoom to fit, and that will just zoom to fit there. Now I think that's actually upside down, so I'm going to go back to my other design. Where is it? The 3D design. I'm going to click on... Well, actually, no, I'm not. I'm gonna leave that for now. But when basically before where I said that the X was pointing the wrong direction, or the Z, it's essentially just done it upside down. It doesn't really matter for what we're doing today. So let me look what we need to do next. So we need to now create the schematic. So I'm going to go over here and click on switch to schematic drawing. Now it doesn't have one, and it'll complain that we don't actually have one created yet. So what I need to do then is just go and create a new electronic design. So if I go up to new electronic design, it will create a new blank document. Now this is kind of like a binder that holds all the three different documents together. So it'll have the 3D model, the 2D model, and this schematic in there. So what I need to do then is create on here a new reference to a new schematic. So let me just find where I'm up to on here. So what I will do, so I'm going to reference the PCB design. So see this button here where it says reference the PCB document. If I click on that one, I then go to the place where we've saved this. So we call this one PCB live stream, and that PCB there, we can link those two together, and we've now got that linkage there. So if I now click on switch to schematic document, it now knows what to do. Right. And if I go back to, let's go back to that document, the one that's got the 3 up, there we go. You can now see that we've got the board layout, the schematic which hasn't got anything in it, and our 3D model which we haven't looked at yet either. Okay, so I'm going to go back to our schematic. I will be jumping backwards and forwards, just bear with me. This is how we do it. Right, oops, let me just get rid of that. Just need to put myself into do not disturb. There we go. Okay, good. You can't see that. Right, so I'm going to save this. So let me go back to that version there. I'm going to click on save. Yeah, we'll just call this one Electronics Design Remote Control, something like that. And that now means that we've got everything saved, just in case Fusion 360 crashes, because sometimes it does do that and it's quite irritating. Okay, so what we're going to do next is we're going to create our schematic. We're going to put in some components, some buttons, and the Raspberry Pi Pico, and a power connector, like a JST PH connector, for example. So what I will do, let me just scroll up a little bit. So I've got a box of the kind of buttons that I want to use here. These are these momentary tack switches. You might have seen these before. I don't know if I can get that to sort of show on camera there, but these are very small little push buttons. So I've got a whole box full of those. That's what I want to use. You can either have surface mount ones or through the hole. I'm probably going to use through the hole for this entire build because it's just easier for me to solder. I don't have all the fancy air guns and things for surface mount. Okay. So what we're going to do then is we're going to put on the buttons onto the PCB, onto this sketch here. We're also going to create our own Raspberry Pi Pico because that doesn't exist in our library yet. So I'm going to show you how to do this. So over here on the left hand side, we've got this idea of libraries. If I click on this little library manager button here, you can see that we have quite a few different libraries that we can pull things from. So there's Eagle, there is Fusion Electronics, there's this, is it Hettel PCB layout? There's quite a few, and there's obviously library.io, which is an Autodesk library. So we can close that if we want to. Sometimes it's easier to search for things in here, but we'll be doing our searching in this filter thing here. So what I want to find, excuse me, is some components. So what I will look for, I've just written it down here. So this is the 10-XX, and it calls this one a switch. And you can see down here we've got three different views. We have the schematic view, we have the PCB board layout with the pads on it that we'll be soldering into, and the drill holes, and any kind of PCB text that will appear on the PCB itself. And if there is a 3D model associated, it will appear here as well. So this one doesn't actually have the 3D model, but I think there is one that does. If I can just find on my notes where that one is, we can grab that. So I think I called it, there we go. So instead of using the 10.xx, we will use the 1-1. You do have to sort of Google things, I think, sometimes to find the names of these components because they're quite esoteric, I would say. Right, there we go. So this one has got that nice 3D model. So if I double click on that and then come over to the canvas over here, I can start laying these out. So I'm just going to do 1, 2, 3, and 4. And these are going to be our up, down, left, and right buttons on our remote control. Okay. Now I also want to have on here a Raspberry Pi Pico, but I don't think there is a Raspberry Pi Pico component out there. So we're going to have to build our own using the tools that we have in Fusion 360 Electronic Design. So the first thing we want to do is create what they call a library. A library stores components. So I'm going to click on New Electronic Library. And what we're going to do, we've got these different views on this library here. So we've got components, we have symbols as it calls them, we have footprints, and then we have the packages. So let's start out with the component. And we're going to create a component, and we're going to call this one Raspberry Pi Pico. So let's call it Raspberry underscore Pi underscore Pico underscore W. And that's going to represent this Raspberry Pi Pico that we have with our Bluetooth controller on it. Okay, so now that we've created that, we need to build some symbols for this. So if we now go to click on, see these buttons up here, we have new component, new symbol, new footprint, and new package. So I'm going to click on new symbol. I'm going to call this one similarly Raspberry Pi Pico W. So now that in this little symbols tab, you can see now that we've got this Raspberry Pi Pico. Right, this is where it gets really cool. So what we want to do is we want to place 20 pads or pins for the Raspberry Pi Pico. So the way that we do this, we will click on this button here, this button that says pin at the top. We click on that, we get this line, and it has like a line and a dot and a label at one end. So what we want to do is, I usually do them spaced apart, sort of 2 blocks. And you can see that there's this grid settings down here. That grid should be on, and it should always be set to not 0.1 inch, or if you're working in millimeters, it's 2.54 millimeters. And that's the distance that all components tend to be pitched at. So the spacing between solder pins, between headers on dew point connectors, they're always the same, and it's just easier to do this. So I need to do 20 of these. So that's 5, 6, 7, 8, 9, 10. 11, 12, luckily it's counting. Now I do find that the scrolling is a bit weird on this. If I scroll, it isn't actually scrolling down, so what you have to do is sort of zoom out a bit and then zoom back in. You can actually pinch to zoom back in, but it's just a bit of an awkward workflow, I find that. I'm hoping they'll improve that over time. 17, 18, 19, and then 20, there we go. So that's the first half of our Raspberry Pi Pico. Now, if I want to click them on the other side, I need to rotate the pins round so they're facing in the opposite direction. So if we click over here, the top right, we've got this rotate button. And if I now click, I've now got the pin pointing in the opposite direction. So let's just go on. Now, actually, the Raspberry Pi Pico has them going numbering down, and then it kind of turns around and comes back up. So I just need to delete those off. So I can use this X over here to just click on these and delete them. Now, if you notice, if I click over here, it's not actually deleting it, it's making a beeping sound. There is, in the very middle of these components, like an origin point. So if you click on the origin point, it will get rid of the component, otherwise it won't do anything. And then you can either press escape, or you can click off the button to get rid of it doing that. Otherwise it'll keep doing that same action as well. That's part of the functionality here. Right, so if I now just click on this zoom to fit, we can carry on with our pin, make sure we're rotated the right way round, so that one there. And then I'm purposely going to put these in the wrong place. They're going to be a bit too close together, and we can see what difference that makes later on. I think on the schematic it doesn't actually matter too much. There we go, so 39, 40, there we go. Now normally we have some kind of rectangle. I could use this rectangle here, but that creates like a filled rectangle, and I don't actually want a filled rectangle there. So what I'll do, I'll just highlight that, delete it. I'm going to use the line instead. I'm just going to create a line drawing like this, because on integrated circuits, on schematics, they tend to have like a box like that describes what it is. You can also put text in there as well. So for example, we could put a little bit of text at the top that just says Pico W, something like that, and then we can just put that at the top there. And that's our the outline of our sketch made, of our symbol. Right, let me just scroll down to my notes and see what else we need to do next. Right, so what we need to do next is we need to name the pins so that they actually make sense in the context of the Raspberry Pi Pico. So if I click on this this name button here, this D1, and I click on that thing there, I can actually then start to name these. So instead of it being pin $1, I can actually call this one GPIO 0, because that's what it is on the Raspberry Pi Pico. And then I can do the same then, so that's GPIO 1, and see, it's automatically suggesting the name there. Now I can take out my my trusty Robot Maker's Almanac, which will be in all good resellers soon when I've finished making it. But the first thing I've got on there is actually some pinouts for the Raspberry Pi Pico. So I'm actually going to just use this as a guide to tell me what is next. So this next one is actually a ground pin, so it's going to be GND. The next one is going to carry on with the GPIO numbering. So if I just press that there, we get GPIO 2. And then it goes all the way down to GPIO 5. So let's just quickly speed run this if we can. This is the kind of boring bit. And then that one is GPIO 5. Then we have another ground pin. So it doesn't matter at this point that it calls it ground 1. That doesn't really matter or change anything at this point. So this is going to be GPIO 6, GPIO 7, GPIO 8, and then GPIO 9 is the last one before there's another ground. Then we have another ground pin, so this is going to be ground 2. We can actually just jump ahead and put the grounds in, actually. That might be a bit easier to... That's going to be ground 4, that's going to be ground 5, that's going to be ground 6, and then that one's going to be ground 7. Okay, so that one then needs to be GPIO 10, I think. Yep. GPIO 10, GPIO 11. I think 13 is the last one before the next ground, yep, and then we've got 14 and 15. Now on the other side they do get a bit more interesting, they don't just follow the usual pattern there, so that's 16, 17, ground, and it goes 18 to 21, so let's do 19, 20, 21. Then we've got the ground, then it's 22, and then we have an interesting one, we have run. Does anybody know what run does on a Raspberry Pi Pico? So the run pin, if you bring that one, I can't remember if it's high or low, if you change the state of that pin, it resets the, it's like the reset button for the Pico. Okay, so the next one is GPIO 26, so it does jump, so it's not 23, it's actually 26. Then the next one is 27, I think. Yep, 27. Oops, let's just do that again. And then we have another ground. Then we have 28. So that's 28. And then this is where we get the rest of the interesting ones. So this one is ADC, and it's voltage ref. No, it's what is it? ADC voltage ref. Okay, then we have the 3 volt 3 out. That's the 3.3 voltage output. Above that we have the 3 volt 3 enable. Then we have the ground, and then we have the VSys. And then we have VBus. There we go. That's our Pico pins. Thank you for bearing with me with that. Okay, let me just save that. Let's just call this one PCB library. Okay, so let's scroll upon my notes and see what we need to do next now that we've done that. Okay, so now that we've called all the pins a name, we've laid them out in the correct order. I mean, really what we could do is just make that a little bit wider, perhaps, like that, just so that it's a bit easier to read some of the pins. And we could even move that inside, maybe at the top there, like that. You can play about with the you know, the alignment of that, so you could have like a center, for example, so that when you put it on there, it's nice and centered. Okie doke. And if you don't like these things cluttering, you can just close them out just by clicking on these arrows and just give yourself a bit more workspace. Now sometimes they get a bit too cluttered and you want to close a particular one but leave the other ones open. So for example, if I wanted to close this inspector, you click on these 3 dots and you can just say collapse dialog, and that one jumps down and you can then expand it back up again. I don't find that particularly intuitive myself, but I do like these moving them out the way ones. Okay, so that's creating the symbol. So next we need to create the footprint. So the symbol is just like the logical diagram. The footprint is how this is physically going to be on the board. Okay, so what we need to do is click on the create new footprint. This is also going to be a Raspberry Pi Pico W. Oops. Pi Pico W. Okay, and we get this sort of dark view now. So what we need to do next is we need to create some pins. Now we can either create surface mounted pins, or we can create some plated through hole PHT pads. And these pads are going to be the physical pads that we see on the back of like a Raspberry Pi Pico. If I can get that to hold up there, you see the sort of gold pads that you solder to. That's essentially what we're going to lay out. So we need to grab hold of, I'm going to use that one there, the PHT, and you can see there that the first design that we've got is just a square with a circle. Now the Raspberry Pi Pico has these kind of styles, so I'm just clicking over here above my head there, and you can use the rotate as well to rotate them if you don't like the the orientation of them. So this one will have a hole where the PCB is going to be drilled through, and then it's also going to have the pad. So if I just do them the same kind of spacing like that. Now, unfortunately, it doesn't actually number these, so I'm going to actually count these up. So we've done, what's that, 5, 6, 7, 8, 9, 9, 10, 11, 12, 13, 14. Let's just do that, and then that. 14, 15, 16, 17, 18, 19, 20. Let me just count them again. 5, 6, 7, 8, 9, 10. 10. Right, that's 10. Now that X there, that sort of crosshair, that's the origin point, and it is actually quite important that we have that origin point somewhere that makes sense. So I'm going to have that origin point as we look at our physical PCB. I'm going to have that on the bottom edge in the middle there. So that means I need to press escape to get out of that pad placing. I'm going to select all these, and I'm just going to move them up so that they're kind of like that there. Again, if I press the zoom to fit, we can see how that's going to look. Now I need to do the exact same thing with pads on the other side. I need to make sure that they're flipped the right way round. I think they are there, so I'm going to guess it's about there. I always get the spacing wrong, but we're going to come back. I did that one wrong as well, so we can use that move tool to just grab it and move it. Like so, and then just move that one there. And then let's just grab that and move that as well. There we go, I was clicking in the wrong place there. So that should be there. Right, let's get back to placing these. And then we can get on to doing the next bit. So there we go. Nearly done. 2 and then 1. Okay, so that's our pins. So I'm now going to save that. Let me just click on save. And we want to next create the package. Make sure I've not missed any steps out there. No, that looks good. Okay, so we just need to create a package next. So the package, it sent me into the 3D Studio. And now at the moment, thanks Bryce for subscribing to the channel. I'm just going to hide off the overlays for a second because I find them, for me, they're a little bit distracting. There we go. Okay, so we haven't actually got anything interesting to put into the package on this side at the moment. So what we can do is, if we were designing, say, a PGA or a BGA, a ball grid array, we could click on that one. If we were creating a chip, we could click on that button there. But we're not doing that. We're doing something a bit more fancy than that. And what we're actually going to do, we're going to cheat for the 3D model. Raspberry Pi have already created the 3D model. So we're actually going to go over to the Raspberry Pi website and grab their 3D model so that we can very simply put this on our screen. So let me just go over to the website. Let's go to raspberrypi.com. If I go to the hardware, let's click on that and go for hardware. I'm going to find the Pico, which is there, and if I scroll down to this document section here, you can see they have these step files. So there's a step file there for the Raspberry Pi Pico W. So if I click on that, it will actually download the step file. And if I come over to Fusion 360 and I go to File and Upload, I can upload that file. So if I go to Select Files, if I find the it's in Downloads, if I find that step file that we just, you do actually have to unzip the step file. But if I just go for, is it called Step? In fact, let me just go over to here 1 second while I just find it. Downloads and Step. I'm just going to double click it. There we go. Got it now. So let me just rename this. Okay, right. So what we've got over here then is a file that I can now go to Select Files. I can find this in my Downloads folder. And if I just make sure that we're sorted by there, it should be called .step. STP. I'm not sure why it's unhelpfully not displaying that. So let's try. Let me just try uploading the zip file. I don't think that actually works properly, but what I'll show you is you basically just upload the STP file. If I go over to here's one I prepared earlier, and I go into here, then we have this Raspberry Pi PicoW file, and we can actually import this into our design. So if I click on Insert into Current Design, I actually have to save the design before I can insert something. So let's call this one PCB 3D model. And I mean, I should have called it Raspberry Pi 3D model to be fair, but let's just insert this into the current design. And we've now got the Raspberry Pi PicoW. They've got this really weird artifact that I noticed on here. That block there shouldn't actually be on this model. I think it's a mistake. So if I go here and just find it, there it is. If I just disable that, that's actually what the Pico should look like. But I'm going to place that there. I'm going to click on Finish for now. And what we need to do is go back and close that. And do some extra steps on here, I guess. Right, so yes, so I think what I should do, instead of doing the new package, if I go back to let me find here it is. So I was saying a bit before about this gets a bit cluttered. I'm going to collapse that one there. It's this one here I'm actually interested in. So if I go back to our Raspberry Pi Pico and I create a new 3D model from there, that's really what I should have done. I'm going to click on Save. You can see here, these are the pads that we created a moment ago. So this is really where we should now import that Raspberry Pi PicoW into our drawing. So let me do that. And that will tell us whether I've got the spacing correct. So if I go to the top view, and I want to see these are not correctly aligned, and maybe they're not correctly spaced. So I'm just going to move this model about until they fit like so. Let me have a look. So yeah, I can see that if I hide that model, these pads here should actually be a couple of blocks that way. So what I will do, I'll just say OK for now. I will go back to our 2D model, and I'm just going to grab these and just move them like so. I'm just going to move them in the opposite direction as well. That might be correct, so let's just save that. I'm then going to go double click on our 3D model. I think we go back there. We can now go back to the top and see if these now correctly align. They're nearly there. I think they need another push across. The thing that's confusing me is I brought in this this model here and it's already got those pads on it, and that's not great. So what we're probably going to do is just remove that. Let's just delete that and then bring a nice fresh one in. So let me find the Raspberry Pi PicoW. Is that the one that we brought in? Let's try that one. Let's insert current design. Yeah, that's better. So now if I move that, no, it's still got the it's still got these other pads on from another model that I did. I don't really want them to be there. That's irritating. Okay, well, we'll just have to stick with it then for now. But what I can see is that they're still not quite right. So if I click OK, I hide that. Okay. Let's hide that. That's what I'm trying to see. You can see that there's got two sets of pads there, and that's not helping me understand what's going on there. Okay, so let me just finish that. And I think they still need to be moved out just a little bit more. So let's just do that. It's wider than you think. And maybe that is correct. So let's try that. Save that. Close that dialog and then click on here again just to open it up. And yeah, they should be over each other. So if we go back to the Pico, and let's just have a look where that is now. So I'm going to leave that for now because I'll spend all day, but basically we need to get these pads aligned with the 3D model. We can either build a 3D model on top of these pads, or you can just bring in an existing 3D model, but you get the idea there. Okay, so what we'll do next then is we are going to then join the pads to the pins. So what we'll do next then, I'm going to go back to the package. Let's go back to the package, which is this one here. Which one is it I need to go to? Is it the component? Yes, right. So now I'm back on this component. I'm going to click on this Add button, and we can add that Raspberry Pi Pico symbol that we've just created onto here. I'm just going to create the one. I don't need more than one. And it recognizes now that we've got 40 pins available. We haven't connected up the pads yet. So if we click on, I think it's, is it connect? No, we need to add a local package first. So if I click on this, we can click on our Raspberry Pi Pico, click OK. And now we can actually connect up the pads to the pins. So we've created pins on our schematic, we've created pads on our 2D design. We now need to match these up. And the way that I found it easiest to do this is to start with the V-bus and the V-sys. So V-bus is the very top pin 40, so we append that to our list. So we would connect that to our list. 39 is V-sys. Run was pin... What was that pin? 30. So if I find pin 30, connect that up. And then if we now find the grounds, we can probably do the grounds next. So ground, our very first ground is connected to pin 3. Our second ground is connected to pin 8. Our next ground is connected to pin 13, I think that is. Yep, pin 13. And then our third ground is connected to, well, fourth ground is connected to pin 18. Then on the other side it's 23. And it's dead easy to do the rest once you've done these, you see. And then we have 28. Then we have 33. And then the last one is on pin 38. Right, okay. Then we've just got these weird ones. Let's get them out of the way. So 33 enable, that is connected to pin 37. Voltage out is connected to 36. And the VREF is 35. Right, so now if we go back to the very top. So GPIO1 is connected, GPIO0 is connected to pin 1, so that we can basically speed run through these now because they're all correctly aligned. OK, click OK, and we've now connected our pins to our pads, and we're pretty much cooking with gas now. I think we're nearly done on there. Let me just have a look if there's anything else we need to do. Nope, that's all good. So we can now save this library. Click OK, and we can actually close that library out actually. We can now come back over to our schematic. Oh, see, I told you Fusion would crash. This is why I save my work so often. Let's just save that, and hopefully we've not lost too much on there. We did save the library though, which is all the hard work we did. Everything else we can very quickly do, but I think we've... Actually, Fusion does save a lot of the files in the background, so once it's done its crash analysis, we can then quickly get back to where we were. But it is something that happens. I guess it's because they've joined two very different packages together. Let me just load up Fusion 360 again. And then once that's loaded, we can get back to it. So the lesson there is always save your work. Okay. So like I said, it will have detected there were some crash files, and we can just go back into them and open them up. But now we can use that Pico that we just created in our schematic. And there isn't much more to do from the building the schematic side. We can now get into placing our components, wiring them up, and then generating the actual output files that we can send off to somewhere like PCBWay to generate our physical real-life PCB. Okay, so I'll just wait for it to come up with that crashed dialog. There we go. So we want to have that one. Let's open up that. And let's open up the others as well. I think it's the other two that are there. Wait for it to do that. And it says if you want to access them later, file and recover documents. Okay. Let's go to file and let's just open up the other ones that we had. So I did save them in that folder that's called PCB Livestream. So let's just open up our electronics remote control. Let's go for that one there. Yes, let's open up that one, thank you. So Fusion is quite helpful with this as well. It recognises if there's a saved version because something crashed. Let's get rid of that panel. Right, so let's go back over to our schematic. Here we go. So now if we go to this library and we search for Raspberry Pi, we should actually find that one that we've just created. So I think I call this one, it's in the library, PCB. This is the one that we've literally just created now. So if I double click that, look what happens when I drag that across. So if I just zoom us out a little bit, zoom to fit, you can see now this is the PCB that we've literally just designed there. So we can move this about, I think it's the origin point. Gone for this. I'm just trying to grab it and move it about a bit. Well, it's complaining about that. I can't remember where it did it. Was it the bottom? Yeah, that is another irritating thing about Fusion. It doesn't tell you where the actual origin point is, but yeah, you get the idea. We can probably move these other things about instead, actually. That's probably an easier thing to do. Let's grab them, and there we go, the center. So what we want to do next is just connect up our pins to our buttons. That's as simple as connecting things up. So we have this net function to do that. We can either just click on the module there and then click over to where we want that to be. So like GPIO 0 would connect to button 0, for example. Then the other side, that would go to ground. Any of the grounds would do. But our diagram is going to get pretty messy if we do this with everything. So, and correct me if I'm wrong if you're an expert in PCB design, but I don't think you connect up all the, basically it's going to undo what I've just done there. So what we would typically do is we would create a little line from here, and then we would name it with this name thing here. And I could just call this one like GPIO 01, 00, for example. And then if I go over here and I do the same thing to this button, and I name that wire the exact same thing, so GPIO 00, it will say, would you like to connect this net to that net there? If I click yes, then there's a hidden wire that goes between that one, and it just creates nice and neat diagrams. So we can do that, and I think we do what we should have done when I clicked on the name function there. It places the label as well, so we can just put the label next to it, and similar with that one, let's place the label wherever. Let's probably just move them out of the way so we've got a bit more working space, and then we would continue in the same vein wiring all these up. So I'll just do a couple more. Let's just do the rest of the buttons very, very quickly, and we'll also do the ground as well. So if I go over here and just name that ground GND and GND, I think I accidentally didn't place the label there. There we go. And then let's just name that one more time. So that's GND. Okay, there we go. And then that one's going to be GPIO 1. That's going to be GPIO 2. And that's going to be GPIO 3. Okay. And then if we just move all these out a little bit, we've got a bit more space to play with. Need to move my little label as well because that didn't move along with it. There we go. And what we would do next then is, so pin 3, any of the pins on the right hand side are ground pins on these buttons, on these momentary switch ones. If I just do a little line, I then name this one to be GND. It will then connect up this ground to that ground over there. It recognises that they're actually the same thing. Now, just for the speed, I'm aware of the time ticking against us here. So what I will do next is I'm going to create a box around all these objects here. Let's get the label in as well. If I right click on that there and I say new group, I can call these buttons, and we get a nice little dotted line, and it's a bit more neater and your diagram can read a bit better. We could also name these if we wanted to. So instead of being U1, U2, U3 and U4, we could have them named as like up, down, left and right if we wanted to. Okay, we would then continue with the rest of the things. So if we had, for example, let's find some power. We do need some power symbols in here. let's grab, I'm going to say 5 volts. So let's just grab 5 volts, put that over there. That's going to be plus 5 volts. We also need to have a ground, so I think if we scroll down, there's a GND as well. And you can choose between various different libraries depending on how you want the symbol to look. So that one, for example, has got like a bar at the bottom. This one has got like a little arrow. I quite like the arrow one. So if I double click that and then come over here, we can have that added to our diagram. And we can also do things like just connect up the 5 volts and the ground. Let's just name that. That's yeah, plus 5 volts is fine there. And then let's just name that one GND like that, and that will also connect up any like a magical air wire over here. We did say we would put a power adapter on as well. I think we're a bit pushed for time, so I'm going to actually leave that one off, but you would essentially come in here and just search for the kind of connector that you are after for that. I'll see if I've got that on my notes actually, to see what that was actually called. So I think let's call this one GST. Let's just see if we've got that very quickly. GST 2mm, is it? Something like that. Let's see what from the model there that we got. It doesn't have a very good 3D model, this one, but it's kind of like what we're after. And if we could actually just join these up directly. So that's the plus 5 volts, and that's the ground going to there. So that's probably not quite what I'm after. I probably could do with rotating round this one. So if you right click, you can actually rotate the symbols, and it will keep rotating each time you click on it as well. So you can get it to be the orientation that you want. So if I did it like that, for example, I could have this. I'm not happy that that net is actually going to the wrong, it's going to both of them. So let's just go to the delete function and get rid of that. Get rid of that little air wire there as well. A little net. And I'm also going to rotate this one round just to make it a bit easier to connect things up. Of course, it always rotates the way I don't want it to be. Right, so the ground is on the top. So if I click on that little net button, I can continue that net there. And then the 5 volts is there. And we can move these around if we want to make them a bit tidier. We can do all that kind of moving things about as well. There we go. Right, that's probably enough for that. Let's just save that again. And what we're going to do next is we're going to move over to our layout. Just making sure there's nothing else we need to cover off there. Right. So now we click on this switch button, switch to PCB document. So if I now click on here, here is our PCB design that came from that original 3D model. And over here on the left bottom over here, we have, if I zoom to fit, we've got our Pico. So we can grab that and we can shove that there, for example. We've also got our buttons, so we can place them where we want them to be. And we can start to, in fact, I've kind of got my PCB board upside down actually, so that's not helping very much. So if we rotate this round, I'm just right clicking to make it rotate. Try and make that rotate again. So yeah, just keep rotating for me. Rotate. There we go, that's better. Oh, I didn't realise you could do it like that. Okay, and if I just drag that over here, they're now in the right orientation. So the very first one, I've just moved the label there by accident. What I'm trying to do is move the button itself. So let's just zoom in so we can see what we're doing there. So where's the origin for the button? That's the origin for the label, and the button is actually there. So this is our very first button. So let's place that one there. The second button then, let's see, did we actually connect that one up? So we haven't connected up these other buttons yet. But let's place them roughly where we want them to be. I want that power thing to be kind of over there because I want the battery to be sort of in this part of the controller. And let's put this one roughly roughly there. We can move these about in the 3D model as well, so we can get them exactly where we want them to be, but that looks about right. So I can see here that these are these air wires. What we need to have is the air wires for all of them connected up to the correct. So if we go back to the schematic diagram, clicking on this button over here, we can then do the same thing. So we can then just click on that little net thing. Let's just click that there. Let's do, okay, I've got that one there. Let's do another one for the ground. Let's do one there, one for the ground, one for the ground, and one for, just do it down there. Make it a bit easier, and then let's just name these ones. So that one is going to be GPIO 1. Yep, we want them to connect up. That can be just, sorry, I just got the little label moved the wrong place. Let's go back and name this one. This is going to be a ground, GND. Yes, I want to connect it. I want the little label to be next to it. This one is going to be GPIO, let's just name that one GPIO 3. Yes, let's put the little label next to it there. Okay, and then this one is going to be ground. Yes, that's going to go over there. And then this one is also going to be a ground. Yes, label next to it there. And then that last one, let's just name that. That's going to be GPIO 2, I think. Yes. Click. Okay, so if I now just save that, and we then click on the switch to the diagram, you can see now that these air wires are now connectly linking up everything. But these are air wires, these are not actual physical traces. What we need to do next is click on this route button, and then we can actually draw out the route as we want it to appear on our PCB. So what I will do for this, I'm going to zoom in a little bit so I actually get it to connect onto the very correct place on that pad. Let's do that for all of the correct ones. If I click on the next one, which is the second one, that's going to go to there. The third one is going to go to there, and then actually the third one is the ground, isn't it? Let's undo that one. It's that one there that needs to be done next. Now also notice that there's these different layers. On this layer thing here, we're on the top layer at the moment, and that's correct for placing routes. But when we're placing other things, we might want to change what they are. Now that's going to be a bit fiddling. We'll have to go round this one down there. And then the final one is going to go to over here. So I guess I probably need to move that button around, otherwise it's going to get fiddly. You see how it's like trying to push its way through an existing route, and you can't do that because they're all on the same layer. So what I'll probably do here is just move this button to a different location. So let's just move this one out a little bit. Let's just move that button over there maybe, and then move that button down there. Okay, maybe that will work a bit better from a point of view of routing. And then let's go back to our route, and then let's just join up that last one to there. Okay, so that's all the positive connections made up. What we need, and we've also got that voltage coming in there as well. So that's interesting because that must be the ground, is it? Yeah, that's the ground that's going to that pin over there. I don't think that's the correct pin for that to connect to, so we'll have to fix that, I suspect. But what we also need to do then is now, yeah, I think I've swapped the left and the right buttons around. Somebody's just saying there in the comments. But what we need to do next is, you can see there we're on the top layer and we're drawing in red. If I press the space bar, it'll toggle it now to the bottom, and we can now connect up things on the bottom of the board. So we can now connect up anything that we want to be connected. So for example, we can connect up all the grounds where we want them to be, like so. I think that one is also connected to there. That is also connected to there. And that is also connected to there. Like so. Okay. Now, if we want to check that we've actually done our wiring correctly, there is this rules, which is the design rule check, I think it is. So if we do the run the design rule check, it will tell us if there's any problems, and it's saying there's an overlap. The overlap is here. And what's happened is I'm on one layer and I'm trying to connect to a surface mounted pin on another layer, and it doesn't like that. So what I need to do is just put that little via there and then go back and then just create a new path between that and that there. And now that the error's gone, we're all good to go. So we've done our little wiring. I need to connect up probably the no, actually I think we're good there. We haven't connected up the plus actually. So what we probably need to do is connect up like a wire between the plus on there and the voltage on the Raspberry Pi Pico. So we could actually go back on to our diagram there, and we can connect that 5 volts to our VSys. So let's just very quickly do that. So we just name that to be plus 5 volts. It'll connect the two together. We can put a little wire there, save that, go back to our board layout, and we've now got that air pin coming from the VSys. So let's just very quickly do the route between that. So let's connect that to there. Let's just run our design check to make sure we're good. We've not done any mistakes. Nope, no errors. That's what we want to see. Perfect. Okay, so now we've got that, we can now push this to our 3D design and see what this now looks like. I always think this is the most exciting bit because you actually get to see what this is going to look like in 3D. So press that. It's now going to repopulate. So don't worry that it says they're out of sync. You're going to see it now build up the PCB in front of our eyes. There we go. So we can now see there are our buttons. There's our Raspberry Pi Pico. Ignore that little bit there. That's just because I used an existing model that already had some pins that were there. But we can actually hide the packages and just see the PCB itself. So you can see we've got like a surface mounted JST-PH connector there. There isn't a 3D model for that, so it's just drawing a little rectangle. We can also see there's that weird glitch on the Raspberry Pi itself. But yeah, this is kind of our PCB. And we can go back and we can edit and put more things on and make more improvements. So the last improvement that I will make, if I go back to push this to our 2D design, it's normal practice to fill the top and bottom of your PCB with like a ground fill. And there's a couple of reasons for doing this. If I just click on the very edge there, click on convert to polygon and copy, we can then say we want this to be on the top layer. Let's click OK. And what it's now done is it's filled all that background with like a ground fill. So you can see we've got our little connectors, and everything around our connectors has got this this ground fill. And we can do the same on the other side of our PCB as well. So we could go back to the bottom, for example, do the same there, convert to oops, let's try and get that very edge, convert to polygon, copy to the bottom, click OK, and we've also got a ground fill on there as well. So there we go. And what we normally do at each point is we would save what we're doing. We would then push that using these push buttons, which is over here. Click on the push button just underneath my face. If I just hide my face for a second, if I jump back to that, I'll just have to wait for it to generate that again. You can see now we've got the ground fill on there as well. Let's go back and push to our 2D design. When I click that button up there, push to 3D, there is a little push button here that I have to press that then pushes everything to the correct place, and it's kind of a cyclical, you're kind of going round and round each time, updating one model to another. Right, so say we were happy with this was our finished design and we were really happy with how this looks. We've run our design rule checks, we've gone back to our, you can only do this in the 2D space, you can click on this rules DRC, we can click on the check button there and it'll run all its tests. It's complaining there about some dimensions of some wires, so you can see there it's got all these weird things, and that's because we did that polygon fill. So maybe if I just undo that a couple of times, there, the error's gone now. We can just do that final push back. So let's just do that push to the 3D model, go back, and then they'll now be back in sync once it's updated that. So we can save that, click OK. We can go back to our 2D model, and now we can actually export this. So we've got to manufacturing, we can click on this export Gerber, NC drill, assembly and drawing output. So if we click on that, look at all these files that get generated. We simply click OK, and it'll ask us where we want to save this. So I can call this one PCB from live stream. And there we go, we've got the PCB from live stream. It's a nice zip file. And if we head back over to our web browser and we do PCBWay, for example, our sponsor today, we can create an order just by uploading these files. So how do we do this? We can upload the PCB files. So we do an online quote. So you could basically just say what the dimensions of this are. I can't remember what it would be. Something like that. 2 layers quote. And then we then upload the files that we're after. You can choose what kind of color PCB you want, which is pretty neat, and how many layers you want to have, what material it is. They pick a lot of defaults for you, so that's all fine. You can even decide if you want some kind of stencil on there. Let's click calculate on there, single piece. Let's just go for 5. Calculate that. Trying to get to the bit where we upload the files. So if we're happy with that, save to cart. Then it asks us to upload our files, and we can click on that. We can grab that zip file that we created. I think it says on here you can either do it as just like an other, and then you can basically just drop all those files in, upload, and away you go. So I did this earlier. So let me click on my cart, and I can show you what happens. So once you've uploaded your files, it goes into this sort of under review. So there we go. So this is one I created earlier. So I decided to go for like a yellow PCB. I created some mounting holes. We can have a look about how to do mounting holes. I've got a through the hole power connector on there as well. You can have a look on the bottom of the board as well. The yellow looks a bit yucky now in retrospect, but yeah, you get the idea there. We can click off that. And then you basically just buy it and get it ordered, get it shipped to you. So that one is like $38 for 5 boards manufactured. And it only takes a couple of weeks for that to come through. So let's just go back here for a second, hot second. If we go back to our very original model that we did, which is probably under here. Let's just find it. So we called it 3D model. So let's go back over here. And that sketch that we created that we based everything from, I think it's the sketch 2 there. If I go and edit that, and I decide I want to add some circles to this, I'm just going to add a circle right on that point there, that one there, that one there. I'm just being really rough and ready with this. And these circles are going to be like 3mm, whatever. Let's just get rid of that. I was trying to get that edge there. So that's going to be 3. That's going to be 3. That's going to be 3. And that's going to be 3. We now finish this. We now save this. This will trigger that there's been an update to this file. We now go back to our electronics design and find the PCB board layout. So let's go for that one there. It should detect that there's been a change to that design. Maybe I need to go into one of these. I think it's the 3D version actually, isn't it? Yeah, see at the top now it says the component is out of date. So I'm going to click on that, and that sketch is now going to include those mounting holes. You can see that we've got those little circles, and there's a button here that says PCB hole. So if we click on PCB hole, we drop it on there, we say that it's 3mm in diameter. We can basically do that the number of times that we want, and if we click on the board, it will actually lock to, it'll snap to that. You see how it sort of snaps to that location there? That's because we draw that circle on there. Let's just do the rest of them. So let's just draw one on the board, lock it to there. Okay, and then the final one just over there. Click, drag, no, drag the wrong thing there. Let's just drag that there and make it 3mm. And we're done. Right, so we now push this change, save the file, push the change. when we go back to our 2D model, you'll notice now that we've got the holes in it. So we can now just save that, click OK. It notices that there's a change here, so it insists that even though you made the change in the 3D environment, you have to then push it back to the 3D environment to keep them all in sync. I do find this a bit silly that you have to keep doing this manually, but this is how it works. So now it's happy that they're there. It's going to regenerate the file, and if we now save that, click OK, and go back to our 2D space, then it's now happy that we've got those mounting holes in there. So we can actually mount our PCB correctly to our 3D enclosure. So that's pretty much how you do the whole workflow end to end. Just over an hour it took us to do that. Now obviously there's a lot more to learning electronics than just placing components, but a lot of the time when we're building things like this, we are working quite simply. It is more just like a breadboard, but we're extending things and putting roots in rather than having DuPont cables connected on our breadboard. So there's a little bit more to learn, I guess, than just learning the software. And it does look a bit overwhelming at first with all those things, but what I've covered there today is the basics of it. It's everything that you need to get up and running there. So let's get back over to our keynotes and see what else we just need to cover off. Yes, if you like what I do, you want to see more of these kinds of videos, then please like this video. Drop me a comment. Let me know what software you use. Are you a KiCad? Is it KiCad or KiCad? Are you using Eagle, or do you use another package such as Fusion 360? Let me know that. And if you haven't subscribed to this channel, it means the world to me. Every time I see a new subscriber, my heart lifts and I feel like I've done something worthwhile. So please subscribe. I do go live every single Sunday at 7 o'clock BST, British summertime currently, and then in the winter months that'll be GMT. But if you're watching this on replay, just know that I go live every single Sunday, UK local time. And if you want to learn more about robotics, whether it's Python, electronics, 3D design, you can find a course over at kevsrobots.com completely for free. There's no sign up or anything, you just jump straight into the courses. It's all very nice and simple. So go to kevsrobots.com/learn/ and you'll find all the courses that we have over there. And of course, we have some merch. We have lots of different coloured hats. We have mugs. We will have very shortly, where's my little book gone that I was using today as a reference? We will have these Robot Maker's Almanac. I think that's what I'm going to call it. It's got all the kind of information that you need when you're building robots to hand, such as pinouts for Raspberry Pi Picos. We've got pinouts for things like ESP32s, pinouts for BBC microbits. What else have we got on there? I'm telling you this, you can't buy it just yet. We've got things like the resistor values, electronic symbols, how to correctly orientate your mechanism wheels, like so, and so on. It's all going to be in there. Snippets of code as well, formulas, functions, all that kind of stuff. But if you want to buy some merch today, you can do that over at our store, our shop. And if you've not joined our Discord group, then you're missing out there. Head over to kevsrobots.com/discord and join our Discord server to become part of that larger community. And I'm all over social media. I've recently joined Threads, so I'm Kevin MacLear at threads.net over there. On Twitter /X, I'm not going to get used to saying this. On X, I'm at KevsMac. At Mastodon Social, it's KevsMac at Mastodon Social. Mastodon, Kevin MacLear on Instagram, and Kevin MacLear 6 on TikTok. So there you go. You can get some behind the scenes craziness, what's going on there, such as what is this red thing that's over here. And if you want to join me, if you want to help support the show, there's a number of different ways you can do that. You can get your name over the get your name on the credits at the end of the show, which I'm going to show in a second. So if you go to kevsrobots.com/coffee, you can buy me a coffee there. If you do a super thanks, you can click on the thanks button underneath the YouTube player, and that's like a one-off thank you kind of thing if you found that this video particularly useful to you. You can do a super chat if you want to get your name up on lights. I shall switch that functionality back on now. I have Stream Elements to help me do that on the show today. And you can also do you can join the YouTube membership program by clicking that join button there as well, and it all helps me continue to buy stuff that I need to make things like the chicken nugget of doom. Okay, so that's the join me. I think the last thing to do is to thank our supporters, so let me bring up the little video clip there. So support-wise, we have Steve Phillips, we've got Slarty Bartfast, I think. We've got Tom, we've got Roland, and Mike as well. Bought me coffees recently. We've got DN Corte, we have Marlene Brent, John Rank, Tom Shemmy, and Steve Phillips, who are on our Buy Me a Coffee membership. And then over on YouTube, we have Tinkering Rocks. We've got Dale, who's joined back again. Thanks, Dale. We've got Cassie, we've got JDM, Johnny Bates, we've got Bill Hoy, Orksrad39, Jose, Javi Gold, we've got Hans, we from Cheerlights. We've got Michael and of course Tom. So thank you so much for supporting the show. It really makes a difference to me. You get your name in the credits. You can go to kesrobots.com/coffee or /credits for either of those. So a bit of a speed run on how to do PCB design today. So I hope you enjoyed that. And if you're watching this on replay, this is the point in the video where I'll say thank you so much for watching, and I shall see you next time.